Hello friends, in this video we are going to discuss the numerical on career lifetime. In the given numerical is written as Pt equals to 5 into 10 to the power 10 plus 4 into 10 to the power 12 e to the power minus t by 10 to the power minus 6 per centimeter cube, and it is given that it is the excess carrier concentration is given by the above equation. So this equation is the excess carrier concentration equation where Pt is the excess carrier that is changing with respect to time. Now we have to find the excess carrier generation rate. Let us find what is the excess carrier generation rate. So for that case, we know that if we see this equation is the excess carrier concentration varying with respect to time. So the general equation where the excess carrier vary with respect to time, we know that that equation is Pt is equals to P0 del P e to the power minus T by tau P, where this P0 is the value of P or the value of the excess carrier concentration at T equals to 0, and del P is the change in the excess carrier concentration due to non-equilibrium process, and this tau P is the carrier lifetime. Now if we compare this equation with the written equation, then we can find that the value of the P, that is the excess carrier concentration at T equals to 0, that is P0, will be equals to 5 into 10 to the power 10 per centimeter cube, and the value of del P, you can find it as 4 into 10 to the power 12 per centimeter cube from the given equation. Now according to the excess carrier generation rate, so the excess carrier generation rate, if we denote this excess carrier generation rate by Gp, we know that Gp equals to del P divided by tau P, and the del P value that we have find is 4 into 10 to the power 12 per centimeter cube, and tau P we have found tau P as tau P is equals to, we compare the both equation, then tau P will be 10 to the power minus 6 second. So tau P will be 10 to the power minus 6 second. So if we calculate this one, then we can find it will be Gp will be 4 into 10 to the power 18 electron hole pair. EHP means electron hole pair per centimeter cube per second. So this is the excess carrier generation rate of the given semiconductor which has a excess carrier concentration of 5 into 10 to the power 10 plus 4 into 10 to the power 12 e to the power minus t by 10 to the power 6 per centimeter cube excess carrier concentration. So in this way, we can calculate the excess carrier generation rate. Thank you.